In this episode, we looked at the physics issues that make ramps so useful. Ramps are simple machines that allow you to use gentle forces to lift and lower heavy loads. You exert those forces uphill as the heavy loads move long distances along the ramp. The story of ramps is also the story of energy and work. It's the story of energy because energy is a conserved quantity that depends only on the situation. So that in this case, the wagon has a certain amount of energy, and now it has more energy. The energy increase in going from here to here is all in the form of gravitational potential energy, the energy stored in the force of gravity. The story of ramps is also the story of work because in going from this position to this position, you have to do a certain amount of work on the wagon to increase its gravitational potential energy from its low value to its high value. You're responsible for that increase in energy. And you can do that, the work necessary to increase the wagon's energy, either by lifting it straight up with a large force exerted as the wagon moves a small distance, or with a gentle force as the wagon moves a long distance. So the work you do via either of these two approaches is and has to be the same because the wagon's increase in energy is the same. In addition to looking at energy and work in this episode, we also looked at a new force, support forces. Support forces appear whenever two surfaces try to occupy the same space at the same time. And those support forces are exerted perpendicular to the surfaces involved. For example, when the surface involved is horizontal, as it is with a sidewalk, the support forces that a horizontal surface exerts are vertical, as indicated by this stick. But if the surface that you're looking to obtain support forces from is tilted, as it is with a ramp, the support forces are no longer vertical. They're still perpendicular to the surface, but that's no longer straight up and down. That up and, in this case, to the right support force from this ramp cannot cancel, in this case, the wagon's downward weight. There's a residual left. When the two forces act on the wagon, the residual that's left is the downhill ramp force, and that ramp force, left unchecked, will cause the wagon to accelerate downhill. We also talked about the third of Newton's laws, Newton's third law of motion, which observes that for every force that one object exerts on a second object, the second object exerts a force back on the first object that's exactly equal in amount and exactly opposite in direction. If what you see, this hand pushes on this hand pushes back on this hand equally hard in the opposite direction. Every time, it does not depend on whether the hands are accelerating or moving in any way they like. Newton's third law works. That's it for ramps. Do your homework, study hard, and I'll see you next time as we continue to look at how things work.